All right, today we're starting lesson 7.5. This is properties of logarithms. We've got three different properties: the product property, quotient property, and power property. So first, product property. This looks like this. Log base b of m times n. So we've just got a log of a number with two things that are being multiplied together. So what we can do is we can take these things and make it equal to log b of m plus log b of n. Another way we can say that is if we have two things that are multiplied together here, we can say we split them and add. Split and add. Okay, keep in mind they're equal, so they can go both ways. If you have two logs of the same base that are being added together, you can combine them and multiply. So if we're going one way, we can split and add. If we're going in the reverse way, we combine and multiply. Okay, the second thing we have is the quotient property. Remember that quotient means dividing. So if we've got, for example, the log base b of m divided by n, so now these two things are being divided instead of multiplied. It's pretty much the same thing. We are going to split them and subtract. So we'll have log base b of m minus log base b of n. And just like with exponents, it's always the top one minus the bottom one. So again, if we're going from dividing, if we're going in the normal way, then we're going to split and subtract. And if we're going in the reverse way, we will combine and divide. Okay, the last property we have is the power property. Power property looks like this. We have a log base b of m to the n power. And whenever we have that, it is the same thing as taking the exponent and moving it to the front. So it could be written as n log base b of m. So basically, if we have an exponent, it can be moved to the front. That's our first option. Our second option is if we're going in the opposite direction, so we're starting with this guy. The guy in the front can be moved to the exponent. Okay, let's work with a few of these properties. Here is example 1. I've got log base 2 of 3. I'm going to tell you that that equals 1.585. I'm also going to tell you that the log base 2 of 7 equals 2.807. We're going to need this information with these first few examples. So example A. I want you to evaluate the problem. We're going to evaluate
Good morning and happy Friday, Skeeters. Teachers, I need you to look at your email from yesterday evening from Mallory Williams, or she may have resent it this morning as well. And anyone on that list, please send to either the ILS room or the library, whichever is next to their name. Thank you.
Sorry about that. So we're going to evaluate the log base 2 of 3/7. Now the first thing you should notice is that we have two things here that are being divided. So we're looking at the quotient property. Whenever we see two things that are being divided, we split and subtract. So what we're going to do is we're going to split them. The log base 2, remember it's always the top minus log base 2 of the bottom, which is 7. Now lucky for us, I just gave you what these things equal. We have log base 2 of 3. Well, I told you already that that equals 1.585. We can plug that in. And we're going to subtract the log base 2 of 7, which we also know is 2.807. Plugging this into your calculator, you get an answer of approximately negative 1.222. Okay, next one. We're going to evaluate again. But this time we have log base 2 of 21. Now the first thing you should notice is nothing's being divided. There's nothing that's being multiplied that I can see, and there sure isn't an exponent. So what we need to start thinking is there anything that we can multiply together to get 21? Can we make this work in our favor? And you should know that we can multiply 7 times 3 to get me 21. So I can rewrite this as log base 2 of 7 times 3. And now I'm back up here at the product property because I have my 7 times 3. So if we have two things that are being multiplied together, we split them and add. So we're going to do log base 2 of 7 plus log base 2 of 3. And again, we have already been given this information. We know what log base 2 of 3 and 7 is, so we're just going to substitute those in. So basically, log base 2 of 7 is 2.807, and we're going to add that to the log base 2 of 3, which is 1.585. Plugging that into your calculator, you get approximately 4.392. Okay, a good way to remember this is how I like to do it. If you are dividing, the division symbol has a subtraction symbol within it. So division and subtraction look much alike. So anytime you see something divided, you know you're going to be subtracting, and vice versa. If you see something that's being subtracted, you know you can easily make that into a division sign. That's how you can remember if you're supposed to be adding or subtracting. Same thing goes with the multiplication, because multiplication signs we're supposed to be adding, and multiplication and adding signs are also very similar. So keep that in mind when trying to remember which one you're supposed to be doing. All right, one more. Here's example C. Again, we're going to evaluate. This time we're going to do the log base 2 of 7 squared. Okay, first thing you should see is that we have an exponent here, and this has got to be the power property. And so we know that if we have an exponent, it moves to the front. So basically, I can just take this guy and move him up here. This gives me 2 log base 2 of 7. Again, I know what log base 2 of 7 is, so I can plug that in. Now remember, we're multiplying, so it's 2 times the log base 2 of 7. And log base 2 of 7 again is 2.807. So now we multiply these two things together using our calculator, and you should get a final answer of 5.614. All right. Part 2, expanding and condensing logs. Now remember, we're going to be using the same properties. Use the properties that we just learned. This is going to be example 2. So this time, instead of evaluating, I want you to expand. And here's your problem. Ln, remember that's the natural log, of 5x to the 7th power divided by y. So first thing that you should notice is that we have two things that are being divided. Remember the signs, dividing and subtracting go together. So if I have two things that are being divided, I know right off the bat I'm going to split them and subtract. So I'm going to have the ln of the top, which is 5x to the 7th, minus ln of y. So natural log of 5x to the 7th power minus natural log of y. Okay, the next thing I need to look for, this can still be expanded further. If you'll notice, don't forget that 5 and x to the 7th power, these two things are being multiplied. Anytime you have things being multiplied, you can split them and add. So that's going to change it to the natural log of 5 plus the natural log of x to the 7th power. And then we still have this minus the natural log of y here. Almost done, except there's one thing that's being left untouched, and that is this exponent here. And we know that exponents have to go to the front. That'll be your final step. So we have the natural log of 5 plus, remember we're going to move this 7 to the front, 7 times the natural log of x minus natural log of y. And now it's expanded. So just to point out where we started, remember the first step, that was your quotient power, quotient property. And then we did our power. Nope, just kidding again. This is our product property, I'm sorry. Product, and then the last step was the power. Kind of did those in 2 steps. Okay, here's example 3. This one, I want you to pause the video and try it on your own. It's another expand. And here's your problem. Log base 6 of 3x to the 4th power. Again, pause this video, try it on your own, come back and watch me work it. Okay, first thing you should notice, 3 and x, those two things are being multiplied together. If anything is multiplied together, we split them and add. That gives me the log base 6 of 3 plus log base 6 of x to the 4th power. Remember that the power is with the x, not with the 3. Next thing you're going to see is this exponent here, which we know needs to be moved to the front. Final answer, log base 6 of 3 plus 4 log base 6 of x. Example 4, this time we're going to condense. Here's your problem. We have the log of 9 plus 3 times the log of 2 minus log 3. Okay, very first thing that we see is that we have a 3 in front. We know that this 3 can be moved back to the exponent. So my log base 9 is going to stay. I'm only going to fix the 3 at this point, so I have log of 2 cubed minus log of 3. Okay, another thing that we should notice is when we have two things that are being multiplied together, when they're being added, we multiply them. So that gives me the log of 9 times 2 cubed. Because anytime we add, we can multiply these two numbers on the outside. And we're going to do minus the log of 3. I'm going to leave that alone for right now. 9 times 2 cubed, your calculator can help you out there. That's going to give you the log of 72 minus log of 3. And remember, I told you, anytime you see that minus sign, it changes very quickly into a division sign. So what that tells me is that I will divide. So I have log of 72 divided by the log of 3. 72 divided by 3 gives me the log of 24. Okay, I'm going to give you another condense. Here's the problem. Log of x minus log of 9. So again, I want you to pause this video and try this one on your own. Come back to it and watch me work through it. Okay, anytime we see that division sign, I don't have any exponents. Notice there are no exponents that need to be moved to the front. The only thing I have is the division, which easily, the subtraction sign. I gave you the answer, which easily turns into a division sign. So our final answer would be log of x divided by log of 9. Now keep in mind that these things can be written a little bit better, if you will. This is the same thing as saying log of x over 9. That would be the better way to write your answer. Okay, one other topic that we need to talk about is the change of base formula. Whenever two things do not have the same base, how can we work with that? Here is the actual formula. Let's see. Okay, log C of A. We can break that down into log A over log C. Keep in mind this also works with the natural log, so you could see the ln of A over the ln of C. This is a formula that you are going to want to know for your test. I would box it, star it, bubble it, do something. Just make sure that you know that formula. Here's example 6. I've got the log base 3 of 8. So your 3 is going to correspond to the C, of course, and your 8 is going to be your A. So in order to figure this out, we can change it to the log base of A, in other words 8, divided by the log of C, in other words 3. Remember that your calculator can do log base 8 and log base 3 because they both have a base of 10. So as long as the bases are the same and they are 10, your calculator is able to calculate that for you. Plugging this in, you get 1.893. Example 7. This time I have the log base 6 of 24. So remember, calculator cannot calculate log base 6. It can only do log base 10. So we can use the change of base formula to figure out what this is. Change of base formula says log of A, which is my big number, divided by the log of C, which is my small number. Now that we have them in both log base 10s, you can plug this into your calculator just pressing the log button. You should get a final answer of 1.774. This would also be the same thing. You could also do your, you could also do the natural log of 24 over the natural log of 6, and you should get the same thing. Answer of 1.774. Give me 1 second. I'm going to grab a calculator so I can show you where those buttons are if you were absent for last class period. Okay, looking at example 7, we had log base 24 and log base 6. So on your calculator, here's your log button. Log of 24, and we're going to divide it by the log of 6. Again, our answer 1.77.